Hi, we have already studied the algorithm for depth first search. We have also looked at a small example on how that depth first search works. In this video, we are going to walk through the algorithm with a very interesting example. A very interesting example. Consider this graph. Here is a graph where you see that 0 is here, 1 is here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So totally there are 15 nodes. We are going to see how the algorithm works starting from 0. We are going to see how the depth first search works, and after reaching the highest depth where it cannot proceed further, how it backtracks and then takes a branch and goes, we are going to see. So this is the graph. Look at the adjacency matrix. So for the code, when you write the Python program, the graph must be given in the form of its adjacency matrix. So here is the adjacency matrix. It is a 15 by 15 matrix where the rows are counted as 0, 1, 2, 3 up to 14, 0 to 14, 15 rows. Similarly, the columns are also numbered as 0 to 14, so 15 columns. Now, let us have a quick relook at the algorithm. The algorithm is very simple. So the node is given, the initial node is given. Start from the initial node, and then what are we going to do? First, you verify whether it has the solution. If the solution is available there, then we are done. If the solution is not available, we will do the following. What is that? Find out what are all the neighbors of that node. For each of the neighbor, do a depth first search and then come back. So, if there are 3 nodes which are neighbors of the initial node, you take the first node and do the depth first search and go till the end. After searching the entire subtree, come back and then you take the second node and do the depth first search, come back, take the third node, do the depth first search. So that is how the algorithm works. So we have already seen that in order to keep track of where is the last node I left, so we maintain a stack. We have already seen that. Now let us look at it. Here is the graph. So I begin from 0. So what I do is I have a stack. So this is the stack. Stack is the last in, first out. If you want to take out, there is only one way. So first we keep 0 inside the stack. So that is the first work. Now we have to explore 0. Verify whether 0 has the solution. If 0 has the solution, we can stop it. If 0 doesn't have the solution, find out what are all the neighbors. 3, 4, 6, 5. So we will do depth first search in each of these things. So what I do is I keep 3 inside the stack, 4 inside the stack, 5 inside the stack, and 6 inside the stack. Look at it. 3, 4, 5, 6. All of them, keep them inside the stack. Now, one by one, we will have to take and do the depth first search. That is the question. Now, if you pull out from the stack, what will come out? 6 will come out. Remember. So, as per the algorithm, 6 will come out. Now, 6 has come out and 3, 4, 5 are waiting in the stack. Now, we have to do depth first search with 6. If you want to do depth first search with 6, what are we going to do? Find out what are all the neighbors. So 0 is already verified for 6. 4 and 5 are there. What shall we do? We look at the stack. We will have to pull out. Now 4 and 5 must be kept inside the stack. Keep 4 inside, 5 inside. It is already there. Now we have to, is there anything else I can do? No, because 4 is already there, 5 is already there, 0 has already been done. So we have reached the end at this point. Now you pull out 1 from the stack. What is that? 5. So 5 comes out. So we started from 0, we went to 6, now we are going to 5. We will have to do the depth first search at 5. Now let us see depth first search at 5. We'll begin from 5, verify whether 5 has the solution. If not, what is the neighbor that is not in the stack? Only 8 is there. So keep 8 in the stack. Now pull out 8 and then verify whether that has the solution. Because for starting from 8, we will have to do the depth first search. So 8 has been pulled out. Now for 8, verify whether 8 has the solution. If 8 has the solution, return success. If 8 doesn't have a solution, we will have to proceed with DFS of 8. Depth first search of 8 will be done by finding out what are the neighbors. 10 and 9 are the neighbors. So put 9 inside, put 10 inside. Now pull out from the stack 10. So now we will start doing DFS of 10. What will happen? So 10 has 13 as the neighbor. So we have to put 13 inside. Now pull 13 and we have to do the DFS at 13. For 13, 11 is a neighbor. So deep. You are going deeper. From 13, you go to 11. Now keep 11 in the stack. Now pull out. 11 will come out. So we will do DFS of 11. So for 11, 1 is the neighbor. So put 1 inside the stack. Now you pull out. For 1, there are 3 neighbors. 2, 3, 7. Remember 3 is already inside the stack. So for 1, 2, 3 and 7 are there. Now 2 and 7 will be inserted because 3 is already there. Now we will pop the stack. What will come out? 7 will come out. Look at it. So 7. Now we will do the DFS at 7. For 7, there are 2 neighbors, 12 and 4. But 4 is already inside the stack. So 12 is there. 12 you push inside the stack. Now you pop 12 and do DFS at 12. For 12, 14 is a neighbor. So push 14 inside the stack. Now when you pull out, 14 is to be explored. After exploring 14, you cannot go further. There is nothing that you can go further. So you have to now backtrack from the stack. In the stack, what is the next one? 2 is the next one. So you will have to go back until you can do something with 2. So 2 is a neighbor of 1 actually. So when 1 was explored, we put 7 and 2 inside the stack. So now when you pull out 2, from 1, the tree branches to 2. For 2, find out what are all the neighbors. 3 and 9, which are already there. So now we have to pull out something from the stack. 9 can be pulled out. But 9 was already the branch from 8. So branch goes from 8 to 9 and now we are doing DFS of 9. For 9, nothing new available. Now backtrack and from the stack you choose 4. 4 is the neighbor of 6. Then finally 3. Now the stack has become empty. So we can't do anything. Now, what am I going to do? The final tree has been got. Look at it. How is the tree? 0. From 0, we go to 6. Look at it. 0 to 6. Then 6 to 4 and 5. Look at it. 6 to 4 and 5. And also another branch to 3. So 0 to 3. Then 5 to 8. From 8, 9 and 10, two branches. Then from 10, 13. From 13 to 11. Then 11 to 1. From 1, 7 and 2. Then from 7, it goes to 12 and 14. So this is the depth first search tree generated by our algorithm. So the algorithm is start from that, find out whether it has a solution. If it doesn't have the solution, then identify the neighbors, keep them in a stack and pull them the last entry and do DFS. After doing DFS, you pull one more, do the DFS. So if you do in this way, when the stack becomes empty, we get everything. Thank you very much.